Hello students, welcome to Drishti IAS. My name is Saloni Nandkyolier, and in this session we are going to talk about India's Shukrayaan mission. Because recently during our Prime Minister Mr. Narendra Modi's visit to Sweden, India and Sweden have signed a Memorandum of Understanding, and now Sweden has formally joined India's Shukrayaan mission. India's Shukrayaan mission that is going to orbit Venus. So the official name is the Venus Orbiter Mission. So a Memorandum of Understanding has been signed between ISRO and the Swedish National Space Agency. So we have this mission that is aimed at understanding the atmosphere of Venus, the climatic conditions on Venus, the volcanic activity, whether or not any active volcanoes are present on the surface of Venus. And in this, Sweden is also going to contribute. How is it going to contribute? It is going to design a scientific instrument, that is the Venusian Neutrals Analyser. Venusian Neutrals Analyser, and this analyzer is actually going to study the neutral particles or even the charged particles that are present over the surface of Venus, in the atmosphere of Venus. Now, why is all this important? We'll understand these things. We'll see what this orbiter wants to do, what this mission wants to do, and why is Venus so important for us. Okay, so let's first understand the static information about the Shukrayaan mission. Shukrayaan mission or the Venus Orbiter mission. This mission, as I told you, is to study Venus's dense atmosphere. Why dense? We will cover that. Dense atmosphere, volcanic surface, weather systems, and super rotating clouds. What are these super rotating clouds? This also we will study while investigating whether Venus ever had conditions suitable for liquid water. Right now, there is no liquid water that is present on the surface of Venus, but scientists, they think that maybe millions and millions of years ago, there were oceans, vast oceans, there was liquid water that was present on Venus. Then what went wrong? What went wrong over these millions of years that now Venus has become absolutely hostile when it comes to supporting life? Okay, so this is what this orbiter mission wants to achieve. Scientists want to study the climatic conditions. They kind of want to redraw the climatic history of Venus to understand how all these interactions are happening. Interactions between the solar winds, interactions on the Venus's atmosphere, how things are happening, that Venus does not support life at the moment. But ever in the past, was there any liquid water that was present? Was there any life? Was it suitable for life in past or not? We're trying to draw that kind of a climatic history. Okay, so the investigation of solar wind interaction with Venusian ionosphere is going to take place, and this mission is scheduled to be launched in March 2028. Okay, so let's discuss what all these things are. For that, we will have to draw a comparison between Earth and Venus. Why is it so important for us to study Venus? Why is Venus becoming, our center of attraction over here? Because if you know that Venus is actually called Earth's twin, right? Venus is considered to be Earth's twin because of these stark similarities that are present in the physical appearance of both the planets, right? In size also, both Venus and Earth, they are comparable. When we talk about mass of both the planets is comparable. Both the planets are made up of same types of material. They are both rocky planets. And they are both inner planets. They're close to the sun. They are both inner planets, right? But the difference over here is that Earth has life. Earth became habitable, but Venus became extremely hostile and inhospitable for life. Why is that? Because of a lot of things that are actually present. The present atmospheric conditions on Venus, they are not habitable. They are not actually in support of life. Okay, so if you talk about the importance of Venus, so Venus has the similar physical appearances when we talk about comparison between Venus and Earth. But unlike Earth, Venus has an extremely high surface temperature of 462 degrees Celsius. 462 degrees Celsius. That is caused by a runaway greenhouse effect that evaporated its water. Let's understand this. Let's break this down. So for life to survive on Earth, we need to have an appropriate temperature, we need to have water, correct? Now, but when we talk about Venus, we are saying that Venus had a runaway greenhouse effect. Runaway greenhouse effect. Because of which the temperature right now is somewhere around 462 degrees Celsius. What is this runaway greenhouse effect? Now, what do you understand by greenhouse effect? Greenhouse effect simply means that there is going to be warming of the atmosphere, because greenhouse gases will be present in the atmosphere and they are going to trap heat. They are going to trap the heat, correct? And then warming of the atmosphere is going to take place. Now, some amount of greenhouse gases have to be present. They are actually desirable, because some amount of greenhouse effect is desirable for life to be existing on a planet. Otherwise, what will happen? Extremely frozen atmosphere is going to be present. If there is no greenhouse gas in the atmosphere, if there is absolutely no greenhouse effect in the atmosphere, then the climatic conditions are going to be frozen. Again, no life. So we need to have an appropriate amount of greenhouse gases in the atmosphere for life also to be sustainable. Right, but what happened in the case of Venus is that there was a runaway greenhouse effect. Runaway greenhouse effect meaning that this greenhouse effect became beyond control. It went beyond control. How? So I told you in the beginning that scientists believe, they think that actually millions of years ago there was liquid water. There were vast ocean stretches, oceans that were present on Venus. Okay, then what happened? Venus is also an inner planet. It is closer to the sun. In fact, if you compare the distance between Venus and sun and Venus and Earth, Venus is closer to the sun. In that case, Venus naturally became hotter. It became hotter. Then what happened? Evaporation of water happened. This evaporation of water gave rise to what? It gave rise to water vapors, correct? It gave rise to water vapors, and now these water vapors started accumulating in the atmosphere. And if you know that water vapor is also a greenhouse gas. Water vapor is actually a greenhouse gas. You have carbon dioxide, you have water vapors. These are all greenhouse gases, correct? So what happened when there was a vast amount of evaporation, rapid evaporation that was happening, that because of that rapid evaporation, a lot of water vapors started accumulating in the atmosphere of Venus. And then again, greenhouse gases accumulation is taking place. Again, more and more heat is getting trapped. And then in turn, more evaporation is happening. So this was like a loop, a feedback loop. Correct. Heat is making water evaporate. Water vapors are being formed. They are rising up. Now the water vapors are getting accumulated. These water vapors are in turn trapping more heat. More heat means more evaporation. More evaporations mean more water vapor. And this cycle kept on continuing for a long period of time. That is why we are saying this was a runaway greenhouse effect. It went beyond control. So much so that the temperature rose to some 462 degrees Celsius. To this extent, we see a temperature rise because of the runaway greenhouse effect. Okay, one reason for having a dense atmosphere, and the atmosphere is also dense because of a huge accumulation of carbon dioxide as well. There is a huge accumulation of carbon dioxide as well, because it is believed that there was a lot of volcanic activity also that was present. A volcanic activity was taking place on the surface of Venus, and when a volcanic eruption happens, CO2 is also released. Now CO2 is also a greenhouse gas. CO2 is being released in huge amounts. CO2 is there, water vapor is there. Again, a runaway greenhouse effect is taking place, and CO2 is also getting accumulated beyond desirable levels. Then again, this is going to make the atmosphere dense. So all these greenhouse gases are going to be trapped, correct? There was a huge accumulation of CO2, there was a huge accumulation of water vapors also. And then when we talk about these volcanic eruptions itself, a lot of sulfur also went into the atmosphere. There was a lot of sulfur dioxide also that was released. Volcanic eruptions release sulfur dioxide. Sulfur dioxide also went up, and that formed, instead of forming normal clouds, it gave rise to sulfur clouds. Acid rain. Sulfur clouds. A lot of water vapors are going up into the atmosphere. Now instead of normal rain taking place, we also have a lot of sulfur dioxide. So both of them are going to react and they are going to give rise to what? Sulfuric acid. And we are going to see acid rain. Corrosion. Correct? Again, hostile. So these were some conditions. Apart from this, the atmosphere became so dense that the atmospheric pressure also went beyond control. So much so that if you compare it with the atmospheric pressure that is present on Earth, it is 93 times higher than what we have on Earth, right? 93 times higher, which means it's like crushing pressure from all sides because the atmosphere is so dense. All of this is happening because of this runaway greenhouse effect that we see, that was continuing for millions and millions of years, and that gave rise to such an hostile environment that no life currently exists on Venus. But scientists are trying to understand whether at all these claims that we are making, that there were vast ocean stretches, there was a lot of liquid water present, was it actually true? Was this planet at one point of time, was it hospitable or not? Or right now when we talk about the volcanic activity, are there any active volcanoes? Because again, scientists believe that there might be some active volcanoes. So are there any active volcanoes? And the normal observation with Venus, it becomes extremely difficult because of the dense atmosphere cover that is there. So it gets extremely difficult. In that case, that's why we are taking help of an orbiter. Because landing is also going to get difficult in comparison of, if you compare lander and orbiter. Orbiting the surface is going to be easier over here. Landing, again, because there's a huge atmospheric pressure, there could be chances of crushing. Then there could also be chances of the scientific equipment getting corroded because we have sulfur, we have H2SO4 also there. So because of all these things, this orbiter mission is expected to help us understand all these things, why these things are existing, why these conditions are existing, and was Venus ever appropriate for life to be sustained. Okay, so these are a few things that we are wanting to study. Other than this, we are also wanting to understand the cloud cover that is present, or the cloud cover that is super rotating on Venus. So if you talk about the rotation of Venus, Venus rotates very slowly in comparison to Earth. It rotates very slowly. It takes 243 Earth days for one rotation on its axis, and the direction is also different. Earth is going to rotate from west to east. Venus rotates from east to west. So the rotation is also in a different direction, and then the rotation is super slow. We are talking about 243 Earth days for one rotation to complete. But if you compare this with the revolution of Venus, how much time is it taking to revolve around the sun? That surprisingly is 225 Earth days only. So a day on Venus is actually longer. It is longer than a year. On Venus. So these are all strange things that are present on Venus, that are mysterious on Venus, and these are the things that we are trying to find answers to. So days are longer in comparison to an year on Venus, and then this rotation of the planet itself is very slow. But when we talk about the cloud cover that is present, or the atmosphere that is present over Venus, that is rotating super fast. So we want to study the super fast cloud rotation as well. Right? So these are the things that this mission wants to study and wants to find answers to. So studying Venus is going to help scientists understand planetary evolution, climate extremes, and the impact of greenhouse gases on a planet's habitability. Correct, because these things, despite of the physical appearances, despite of the built-up of material that is present in Earth and Venus, we see one of these planets becoming extremely hostile for sustaining life because of the atmospheric conditions, because of the extreme climatic conditions, and because of the greenhouse cover that is present on the surface of Venus. So that's why we want to study this. We want to redraw the climatic history, and we also want to understand whether such things can take place, not on Earth, on Earth, not exactly right now, but in future, future, in let's say after millions of years, can you expect such a thing to happen in case of Earth also? So in order to study all these things, this orbiter mission is going to help us. And when we talk about Sweden's contribution over here, it's about the Venusian Neutrals Analyser, correct? And this is going to understand, or this is going to help us study the neutral particles that are present over the surface of Venus. Because for this extreme heat that we were saying, we said that there is a dense atmosphere because Venus got hotter. Because the distance is distance is less in comparison to Earth. So one reason was that, okay, Venus got hotter. The second reason is that Venus does not have a strong magnetic field like Earth. Venus does not have a strong magnetic field, and the strong magnetic field of Earth actually helps us or protects the surface from solar winds, right? From solar winds, the harmful solar winds. The atmosphere of Earth is not stripped away or stripped off from solar winds because we have a strong magnetic field, which is lacking in the case of Venus. So Venus does not have a strong magnetic field, which means that the solar winds are going to actually strip off the lighter elements of the atmosphere. And what is going to be left? Again, only the dense part of the atmosphere. That's why we say that the Venusian atmosphere is actually very dense. Because of the effect of solar winds also, all these lighter elements have been stripped off. We're talking about hydrogen, we're talking about oxygen. They have mostly been stripped off because of these extreme solar winds also, and the lack of a strong magnetic field. So this analyzer is going to help us study all these neutral atoms, neutral hydrogen atoms, neutral oxygen atoms, and what role did solar winds exactly play over here. How strong can this stripping off be? What is the kind of reaction that takes place? All these things are going to be analyzed by this analyzer, and this is going to help us redraw the entire climatic history of what exactly would have happened on Venus, how the interaction would have taken place between the solar winds and the lighter elements. Okay, so these are the things that we want to achieve with this orbiter mission. The mission is scheduled for March 2028. Sweden is going to help us. It is going to give us what? The Venusian Neutral Analyzer. And with this mission, we are wanting to understand the climatic conditions, atmospheric conditions on Venus, and whether at any point in time it was actually habitable for life. Now, is India the only country that is trying to study Venus? No. There have been other countries because of the intriguing, let's say, personality that Venus has, the intriguing atmosphere that Venus has, that the rotation is taking such a long duration of time, but revolution is faster than rotation. Days are longer than a year, and then we are saying that the planet itself is rotating so slow, but the atmosphere over it is rotating so fast. So all these are very intriguing things about Venus that scientists are trying to find answers to. Scientists all over the world. So we have several countries that have studied Venus, including US, USSR, Japan, and a joint mission by the European Space Agency with Japan. We have future missions which include Da Vinci of US, Veritas, and ESA's Envision mission, which is scheduled for 2030. And VOM, India's VOM is for 2028, March 2028, right? So that was all for this video. I hope you enjoyed the discussion we had today. Now let us look at a practice question for prelims. Consider the following statements regarding Venus. 1. Venus is often called Earth's twin because it is similar in mass, density, and size. 2. Venus has water in liquid form on its surface. Which of the statements given above is or are correct? A. 1 only, B. 2 only, C. both 1 and 2, or D. neither 1 nor 2. Please attempt this question and provide your answers in the comment section. Thank you for watching.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.